Good morning, ladies and gentlemen. Today I'll be presenting a paper titled Solving Privacy and Security Challenges Using ZKP, Its Positive Impact on the Economy. A quick overview of today's presentation. I'll be looking at the background, introduction, methodology, results, discussions, and conclusion. So the basis of our paper is the Industrial Revolution. So from the 1800s to the present, Industrial Revolution introduced concepts such as mechanization, automation, and digital transformation. However, it has led to issues like pollution and working conditions. The fourth and fifth Industrial Revolution has examined the integration of robots, digital technologies and robots to boost efficiency, but has also raised concerns of data security, privacy, and the negative impacts it may have on the economy. And the fourth and fifth Industrial Revolution, also alongside the rapid development of information and communication technologies, disrupted the global economy, and this could result in more economic losses. So digital technologies became more prominent during the COVID-19 pandemic, and during this time we saw a rise in cybercrimes, at the cybercrime rate, and our research has led us to find that the global economic cost of cyber insecurity is projected to reach 63.25 trillion by 2025 if security challenges are not addressed. But cybercrime is not a new concept or a new problem. In 2017, the WannaCry ransomware attack caused over 73 billion rands in economic losses, affecting 230 computers in 150 countries. So what is cybercrime? Cybercrime in terms of data is related to the unlawful access of data on a computer system. This definition then raises the point of these two problems, which are data privacy and data security. Data security focuses on preventing unauthorized access, while data privacy involves properly managing personal or organizational information. So with our research, we were hoping to use ZKP, or Zero Knowledge Proofs, as a solution for these problems. ZKP is a cryptographic method for verifying specified information to a verifier without disclosing secrets. So the prover has to prove that they know a specific piece of information to the verifier in order to access the system. In our methodology, we use the qualitative literature review on data privacy and security to investigate the key challenges of ZKP and how it can be used, of data security and data privacy, and how ZKP can be used to improve data and security. Literature ranged from 2020 to 2024 to track the latest changes of data security and privacy that have affected major technologies in the fourth and fifth Industrial Revolution. Scholarly databases such as the IEEE Explore, ACM, Digital Library, and Web of Science were used. The outcomes of this research included privacy and security issues where ZKP can be used as a solution. So in our results, these are the technologies that we found in our research, namely cloud computing, big data, blockchain, IoT, Internet of Things, 5G, artificial intelligence, and supply chain. So the key challenges are as follows. In cloud computing, which stores a vast amount of sensitive information, we found that unauthorized access and data leakage, as well as API security vulnerabilities are key challenges. In big data, privacy concerns, data breaches, and lack of standardizations are the key challenges here. In blockchain, transparency issues and unauthorized access. In Internet of Things, limited security features and data integrity issues. In 5G, which connects a lot of devices at once, we found that user privacy, resource management, and handover authentication are the key challenges. In artificial intelligence, we found adversarial attacks, data quality issues as their key challenges. And lastly, in supply chain, which interconnects systems in organizations mostly, we found that fraudulent activities and scalability, as well as interoperability, are their key challenges. So for solutions, we have looked at ZKP as well as other technologies or other solutions that could be used for these data privacy and security challenges. So here we recommended post-quantum encryption, AI-based security, and the ZKP cryptographic technique that will help ensure data integrity. In big data, we recommended de-identification secure views and a ZKP cryptographic technique to help maintain sensitive information and privacy. Blockchain, we offered a ZKP technical cryptographic technique that will help enhance security. In IoT, we recommended quantum cryptography as a ZKP as well as blockchain to help improve security for identity authentication and ensure secure transmission of data between the devices. In 5G, we recommend blockchain and ZKP to help ensure efficient privacy in the 5G network and ensure secure communication between all connected devices. In artificial intelligence, we recommended adversarial training, data cleaning, and data validation techniques, as well as ZKP cryptographic techniques that will help maintain data confidentiality. And lastly, in blockchain, supply chain rather, we recommend blockchain, ZKP, and ECC, epileptic curve cryptography, to help validate goods, certifications, and transaction records without exposing sensitive information and maintaining data integrity and preventing fraudulent activities within the networks. So in our discussions, we found that ZKP offers various benefits when combined with these various technologies, including 5G network security, IoT security, and blockchain privacy enhancement. And in technological integration, we found that there is an emphasis of ZKP in these various technologies. In collaboration, we found that there is an importance in collaborating between industries, researchers, and policymakers to develop comprehensive security frameworks and standards. And in order to close the gap, we found that the integration of technology, people, and processes as the key pillars of data privacy and security will be very beneficial. And in conclusion, we found that these technologies are indirectly linked together to fight the problem of security and privacy, and that the leading technology in terms of ZKP is blockchain. And the usage of ZKP in other technologies is still at a very early stage in most research that we found, and further research will help examine each of these complex and critical technologies in further detail. Thank you.
Thank you very much. It's certainly an interesting challenge. Any questions around this paper?
ZKP, zero knowledge proofs. Did I get that part right? Can you perhaps give an example of one of these suggestions of yours, or do you give an example in a paper to make it a bit more concrete? Because you know, zero knowledge proofs are used often in protocols to authenticate. But I don't really see how it extends in the particular examples or cases you put there. If you can maybe just give an example to make it a bit more concrete.
You'd like for me to explain on one of the solutions that we offered? Yes. Oh, okay. So here, let me see. All right, so in the case of maybe, let's say, cloud computing, as I had explained, that cloud computing handles vast and large amounts of sensitive data. Right, so the use of ZKP, applying a ZKP protocol would help enhance their security through the fact that ZKP protocols do not only allow people with specific access or information to access that specific system. So adding a ZKP protocol means that only those with the necessary credentials can enter into the blockchain system. Be the blockchain system be used for whatever reason in that specific organization. I'm sorry, I'm not sure if I'm answering the question correctly.
So let's take cloud computing as an example. So
right.
if I understand your example correctly, you say that you use the ZKP to grant access to cloud computing.
Yes, to the
Okay.
cloud computing system, yes.
Okay, but how does that differ from the fact that I authenticate initially with the ZKP protocol to a cloud computing system?
Okay, so let me just make a simple or clear, like a little simple example, right? So in terms of authentication, it can authenticate, yes, but let's say the system is a house, right? We live in this house and we both come to the conference. We leave the key at a specific location, right? Only we know where the key is. So if anybody else in this room would try to enter that house, they would be unable to because they do not know where that specific key is, right? So that's how ZKP works. So in terms of verifying an authentication, it is a lot stronger than most authentication processes. I don't know if I'm making sense. Okay.
It sounds like you're still
Saying the same.
Yeah,
Okay.
You're still describing an authentication protocol.
Okay.
So let me put it this way. The whole concept of ZKP comes a lot out of the crypto environment where we've got protocols and we need to prove possession of something, right? And that's used as a way to say, so I'm saying I am the specific person. They say prove it, and I have to prove that I've got access to some sort of secret. That's normally the idea, but I shouldn't reveal the secret. So that in my view is what we do when we log into cloud computing. We are using an underlying protocol, usually a cryptographic protocol for authentication. So I don't see how you use that in cloud computing other than what we're already doing.
Okay. So in terms of this question, may I just suggest that you give me your email so that we can send you our previous work, rather. Yes, thank you.
Thank you very much. One last question for you. Are there any others from the audience? Right, I've got one for you.
Okay.
Your suggestion for using ECC, what was your rationale behind that?
ECC. So, since, okay, ECC, right? May I get back to you on that one as well? Thank you.
All right, thank you very much. All right, we're running a little bit ahead of time, which is not a problem, but our last